super duper.
Okay, so if we just look at this equation, we should be able to tell certain. First of all, we should know that y max is 6 meters. Is that everyone? Okay. So then we know these are gonna occur at half the displacement, right? Whatever.
So basically theta what?
So what does the 7 pi tell us?
The amount of how much? That's the amount of
Huh?
oscillation.
Right, yeah, it's gonna tell us like how big or small the wavelength is, like how fast it's oscillating. So we know if this went, and this is cosine, so it went from 6 because at time 0, cosine's 1, right? So it's at 6 through one phase. It's 3. We're halfway through this first phase. So, or I mean halfway down to 0, sorry, not halfway through the first phase. So about how far away through the whole phase? Right, we're like 1/8. We're 1/8 of the total period, right?
How do you figure that?
Well, there's 4 pieces.
Yeah, because
Halfway
4
through
pieces
one.
and then half of 1/4. So max.
Yeah. So it's gonna. So, but I mean, we're somewhere in this region. Is everybody cool with that? Okay. So how do we figure out what is theta when we're So how do we use thoughts? What's that?
Look at the 3, ignore 7 pi t and so forth.
Oh, I see. Okay. So Anne's just saying put 3 here, and then
Make that whole thing theta and then solve for theta.
because do you see what is 7 pi? 7 pi is actually just omega, yeah? And do you remember yesterday we said omega was theta over t, I think it was yesterday. So theta is omega t. Remember that? We just said theta is omega t is a replacement for that, right? So if you want to find theta, this equals theta, right? So then all we need to do is if I put in this 3 for the 1, then that means theta is going to be the inverse of 1/2. Okay, now who are having an aneurysm?
Kind of.
Okay,
No.
so that requires that we do some extra stuff. Yesterday we talked about, well, let's just talk about the cosine function. This is the cosine function. Do you understand what this means? Do you understand what this represents? Yeah, it's just the ratio, right? This is the cosine of theta, which is nothing more than the ratio adjacent side over the hypotenuse of a triangle. And like if this is your triangle, right, and this is theta, and this side, and this is your hypotenuse, then as you this thing from horizontal and then take it all the way around, this is what happens in this ratio. Okay, and all we're doing is describing the thetas just sort of describe the positions that we're at. So that goes through there. My point being, does everyone here understand that cosine of theta is nothing more than a decimal? That's it. It's always just a decimal. It's less than 1. Okay, so if we understand cosine of theta is nothing more than a fraction, if I take an angle, do this machine, cosine or sine or tangent, it spits out a decimal. So does it make sense to you that if I pull the gear and put the machine in, if I take that decimal, throw it into the reversed cosine or inverse cosine, it spits out an angle, right? So cosine is cosine, sine, tangent, whatever. It's this magic box. And if you throw in a theta, you get out a fraction.
Wow.
So likewise, if you put it in reverse and do the subtraction, or the inverse, sorry, you get this. So, huh? Okay, yeah, I mean, it works. You just have to make sure that you have your measurements in the right measurements in the right measurements in the right you plug. If you're in radians and you plug in 30 degrees, you're not going to get 0.866 because you're doing 30 radians, which is much different. So just make sure you're in the right angles. But everybody get the whole idea about inverse. So if you look at your calculator, you see sine, cosine, tangent. It's this little minus sign up here. Okay, and that means that's the reverse gear. That's all that means. So when we looked at this, what we said was, hey, wait a minute, you can't fool me with this gibberish here, right? I know that that just means theta. Then I can just solve for this whole thing and I'll be fine. Well, this says, you know, after I do the algebra initially, cosine theta is equal to 1/2. And that's where we say, oh, what do? Put it in reverse. And put it in this notation. Inverse cosine of 1/2. Right, and that's going to spit out 60 degrees. Yeah, yeah. We usually use degrees in here. For we use degrees. For angular velocity, we use radians per second. Okay, questions? All right, so if that occurs at degrees, so when is displacement 3 meters again? Well, that would right here, right? Because it's 3 meters displacement. Now this depends. Let me look at the quick. Ah, see the case is it positive? It's not the answer. Be like what, 150, 50? 150, and then over here, this will be what? That's 90, 180, 210. So that's 210. This is 210. Okay. Oh yeah, 180 plus 30, or plus that. Okay, and then this is going to be when we're back to our thing here, right? Yeah, and this is, what is it, 300? Does that make sense? Yeah.
Wait, so does the point from the 3 to the does the point from the first time 3 to the second time 3 means the the period to the same spot?
It's not exactly the same spot, is it? What I do, let me see, to get to the same spot is I'd have to do this again. Right? And then that's the same spot. It's the same spot. That is T. Does that make sense? So we do in fact 3 meters. That part is correct. But it's not exactly the same identical meters. Because it's not in sense. You also might say it's not in phase. Right? Because that's 3 meters, but you see we're shifted by 60 degrees. So in order to be in phase, we'd have to go all the way out to this one. All right? So that's good for A. For A, we did that. And, oh wait, just to write this down. This one was 60 degrees. This one was 300 degrees.
Yeah.
And C, does it have the same velocity at these two instances? So the answer should be? No. Does it have the same speed?
Yes.
Yeah, right? Because do you see what's happening here? Which way are you going here? I'm going towards the equilibrium point, but where am I going here? Away from the equilibrium point. Same magnitude, opposite directions. So that's a tricky question. If they would have said, do they have the same speed, then you would have said.
So it would be it has the same speed.
Exactly. And what phase will the oscillator, extreme value for the first time? Technically 0, yeah?
Zero.
Oh, no, sorry. Did it say it's position or velocity? Oh, velocity reaches maximum. Okay, obviously where's velocity? Where's maximum going to be?
360.
Interesting. Okay, do this graph on your paper, and then X the spots where velocity is maximum. Do that for me real quick. And I'm just going to end this real quick. The maximum velocity points are here and here.
Why?
Oh, yeah.
Oh.
Remember the rubber band thing with Wile E. Coyote? Wile E. Coyote is going to be when there is no acceleration, and that will be at the equilibrium point.
Wait.
Wait, where did you put that?
Right here.
Oh,
The 2 points where you cross that. Because remember, at the maxima and minima, you have 0 velocity, but you have maximum acceleration. Maximum velocity is at pi over 2 and whatever, 3 pi over 2 or whatever it is. Okay?
Does it matter what the sign is?
Um,
Because that the velocity goes down.
I guess, but how would you say? I would say both. I would accept both because that's kind of correct terms because they have the same magnitude. Okay, so that's good for that one.